All right, this is Chapter 10, Section 3, Areas of a Regular Polygon. Your learning objective today is that you will find the area of a regular polygon. Before we shuffle off to Buffalo and talk about area of regular polygons, it's important we know what regular means. What does it mean to be a regular polygon? All your sides and your angles are congruent. And if you did not know that, please write that down on your paper, because we're going to use that property to find area and angles and all that stuff. So if you have lost the definition for a regular polygon, make sure you write that down so that you can reference it back. Because when we take the Chapter 10 test, if you don't know what a regular polygon is, that's previous chapter's information. It's nice to have that available and accessible for you. All right, so problem number 1 is finding angle measures. So the figure at the right here is a regular pentagon with a radii and an apothem. So the reason we care, hold it down. The apothem is the distance from the center of your polygon and bisects the side at a perpendicular bisector. So that's an apothem. We're going to use that later to find the area. The item in question here is we're just finding angle measure. So the measure of angle 1 right here, the measure of angle 1 is the way we find it, because we're a regular polygon. All our angles and all of our sides are congruent. So we take 360 and divide it by the number of sides. So the measure of angle 1 is 360 divided by 5, which is 72. So that angle 1 is 72 degrees. Angle 2 is this angle right adjacent to angle 1. We know that the apothem bisects the vertex angle, so we can say it is just 1/2 the measure of angle 1. So what is half of 72? You guys got 46?
No, 30.
36? Okay, thank you. So half of 72 is 36. So the measure of angle 2 is 36 degrees. I've added this little think question. How do you know the radii make isosceles triangles? Since the pentagon is a regular pentagon, the radii are congruent. So the triangle made 2 adjacent radii and a side of a polygon is an isosceles triangle. So this little guy right here. This little green triangle is isosceles. All right, so we're almost done. We have to find that third angle. So if angle 1 is 72, angle 2 is 36, way long days ago we learned triangle sum theorem, which I did warn you, we're going to use the heck out of it in geometry, and it doesn't go away in Algebra 2, and it's something that stays with us for the rest of our careers. To find the measure of angle 3, come on, go. We are going to use triangle sum, which is 90 degrees, which here's our 90. This little corner, angle 2 is 36 that we found. So angle 2 is 36. Plus angle 3 is 180 degrees. So 90 and 36 is 126. So 180 minus 126 is 54 degrees. And then we, just in case, we go back to our original question, what is the measure of each numbered angle? Okay, so put it all together. Angle 1 is 72, angle 3 is 36, or sorry, angle 2 is 36, and angle 3 is 54. So we're going to make sure we got it by doing the same thing with a regular octagon. So if I am an octagon, I have 8 sides, like an octopus. And so I'm going to take, the first thing I want to do is find angle 1. So I'm going to take 360 and divide it by 8. So 360 divided by 8 is 45 degrees. So I'm just going to take this little triangle here and blow it up. All right, so this triangle here is the same as the other one. I just blew it up, samesies. So I have my apothem, which comes right down the middle and makes a 90-degree angle. I have angle 3 here in the corner. Angle 2 lives right here. And angle 1 we found was 45 degrees. So if you remember, the measure of angle 2 was half whatever angle 1 was. Half of 45, well, half of 40 is 20. Half of 5 is 2.5. So now the measure of angle 2 is 22.5. Now we're going to use this red right triangle right here to find the measure of angle 3. I know that this corner is 90. That one's 22.5. And the measure of angle 3 has to be 180 minus 90 minus 22.5. All right, so 180 minus 90 minus 22.5, I am guessing, is 67.5. So if we look here, that corresponds to answer A. All right, so the area of a regular polygon is 1/2 the apothem times the perimeter. A decagon has 10 sides. The perimeter is 10 times the side length, which in this case is 8. 10 times 8 is 80, so our perimeter that we're going to use in this formula is 80. Our apothem is 12.3. And when you multiply 1/2 times 12.3 times 80, you get 492. So the regular decagon has an area of 492. So let's just do a double check to make sure we have this idea. What is the area of a regular pentagon? And just for funds, I make sure I draw the picture. Thanks to the Department of Defense, I know what a pentagon shape looks like. The 8 centimeters is the apothem. And it has an 11.6 centimeter side. So the first thing, if I look at my formula, I want to find, well, I have the apothem, so that's awesome, but I do not have the perimeter. So I want to find my perimeter. It's 11.6 times 5. 11 times 5 is 55. 0.6 times 5 is 3. 55 plus 3 is 58. So now I can put 58 in for my perimeter. and do the multiplication. I know that 1/2 of 8 is 4. And I got 4 times 58. Well, 4 times 50 is 200, and 4 times 8 is 32. So my guess is 200 and 88. Which is answer C. Any questions on that? All right, third problem. A honeycomb is made up of irregular hexagonal cells. The length of a side of a cell is 3 millimeters. What is the area? So thankfully, bees make regular hexagons. Coincidental enough for us. Somebody has measured them and found that the length of the cell is 3 millimeters. We need to find the area of the cell. So our goal is to find the information needed. A is equal to 1/2 the apothem times perimeter. The first thing we need to do is find the apothem. And I'm going to label that A. So what's going to happen here is we're going to find the measure of the central angle. So if I have a hexagon that takes our 360 degrees and cuts it into 6 different parts, and that means each little part is 60 degrees. So the measure of the central angle is 60 degrees. Crazy thing is, here is your cue. Special triangles. There are 2 special triangles that we focus on. The first one, and the one we're going to use here, is a 30, 60, 90 triangle. And we have our short side S. We have our hypotenuse 2S. And we have our long side S root 3. Now, how does that compare with here? So I have this blue triangle right here. And I'm only going to look at half of it. So I'm going to cut it in half. If this whole thing is 3, what is half of it? All of it's 3. Half of it is 1.5. If this whole angle is 60, what is half? 30. So now my little triangle over here, just looking at the half of it, is 1.5 for our short side. You guys agree? If this is 90, this is 30, this little bottom angle here has to be 60. So I have a 30, 60, 90 triangle. So the hypotenuse has to be 2 times 1.5, which is 3. And then our apothem, our short side, is 1.5 times the square root of 3. So when it says find the apothem, we know that is 1.5 square root of 3 because of our special right triangle. All right, so once we know the apothem, we can find the area. So the formula for the area, again, is 1/2 the apothem times the perimeter, although we didn't technically find the perimeter. The perimeter is 3 times 6, because I have 6 sides, which is 18. Then the apothem is 1.5 times the square root of 3. So when you guys see these problems, it will seem like you don't have enough information to solve it, but if you remember, you have special right triangle, and that the relationship is half the side length times square root of 3, you do have enough information. So look to your special right triangles when it feels like you don't have enough information. All right, so when you multiply all these out, and because root 3 is irrational, it's just going to give you a non-repeating, non-terminating decimal. So it's 23.4 square millimeters, which is about 23 millimeters. All right, let's see if we can apply that to this problem. The side of a regular hexagon is 16 feet. So let's put a regular hexagon here. What is the area of the hexagon? Remember, if my central angle is 60, and I cut that in half, then I have 30. So if I look at this little blue triangle, the whole of it is 16, but I only want half of it. So half of 16 is 8. This is 60. This is 30. This is 8 times 2 that we don't need. This is 8 times the square root of 3. So our apothem is 8 times the square root of 3. So if I have my formula for the area of a regular polygon, it's the apothem times the perimeter. Remember, perimeter is 16 times 6. 10 times 6 is 60, and 6 times 6 is 36. So that's 96 for our perimeter. Then you want to multiply all those together. And let me show you how I would do that on the calculator that I have. I would go 1/2, which is also 0.5, times 8, times the square root of 3, times 96. 665.1. It says round to the nearest square foot, so I say it's 665. So when I look at my multiple choice answers, it is B.